Now that our model is built, let's examine how well it performs. There are many ways to evaluate models, but the bottom line is to evaluate predictive accuracy. If our model cannot generalize to instances it has not seen, in most cases it is not a very useful model. First, we'll evaluate our model on both a training set and a test set. On the training data, our model produced a mean squared error of 32.87 and an R-squared of 0.072. We can also run this cell to visualize the performance of our model. The green line is our actual interselection times of starburst. The blue line represents our predicted interselection time. Now we can see a couple of things in this plot. First, the prediction is missing the occasional bursts and drops in demand. Second, it seems unnecessarily wiggly. It's clear that we must return to a choice that we made earlier to improve the performance of our model. Let's continue adding to our diagram on the right side over here. It's clear that we must return to a choice we made earlier to improve the performance of our model. For example, we might want to revisit the feature selection phase, or we might want to switch to a different model to use the same features. The highly wiggly behavior of our regression function suggests that our model suffers from overfitting. Let's try to address this by returning to the question phase and reducing our feature set to the top 3 performing features. Specifically, we will update our statistical inference problem from this expression to this expression, in which we only use the interselection time of Airheads, Hershey's, and KitKat. Let's add a new Q node to the tree to reflect our update.